Tonight, we're going to talk about the fact that the air you are breathing right now is temporary, and that somebody has put a date on it. Not a date anybody alive needs to think about, but a real one, calculated with error bars, published in a journal, and considerably closer than the last one anybody worked out. Earth's atmosphere is about 21% oxygen. That number feels permanent, because nothing in your life has ever moved it. Every breath you have ever taken came out of the same air at the same ratio. Every animal that has ever existed has depended on it staying where it is. It has not always been there. For most of this planet's history, there was almost none of it, and nothing here needed any. And it is not staying. But here's the question almost nobody asks. If oxygen arrived at a particular time, for a particular reason, then what happens to this world when that reason stops? Tonight we're going to follow that the whole way down. How long the air lasts, what takes it, and what is still alive here afterward. Start with the number, because it is more specific than you would expect. In 2021, 2 researchers published a figure for how much longer this planet stays breathable, and the figure is 1.08 billion years. Their names are Kazumi Ozaki and Christopher Reinhard. One works in Japan, one in Georgia. What they built was a model of the whole system at once, the air and the ocean and the rock and the life, all of it feeding back into each other the way it actually does. Then they ran it more than 400,000 times. They ran it that many times because nobody knows the exact values for a planet a billion years from now. So instead of guessing once, they guessed hundreds of thousands of times across every reasonable range and looked at where the answers piled up. They piled up at 1.08 billion years, give or take about 140 million. That is the point at which the oxygen in this atmosphere collapses. Not thins, not declines, collapses down to something like a millionth of what you are breathing and stays there. The reason is short enough to say now, and we will come back to it properly later tonight. The sun is getting brighter. It has been doing that since it lit, and it does not stop. A brighter sun warms this planet, and a warmer planet pulls carbon dioxide out of its own air faster, and plants cannot live without carbon dioxide. When the plants go, the thing that makes oxygen goes with them, and oxygen does not sit still on its own. It reacts with everything. Stop making it, and it disappears. That is the whole chain. A star gets hotter, and a billion years later nothing here can breathe. The part of that number worth sitting with is not the size of it, it is the shape of it. Before this paper, the working figure was around 2 billion years. That was the standard answer, and it was based on when the oceans boil off. Ozaki and Reinhard did not touch the oceans. They looked at the air instead, and found that the air fails first by a wide margin. So the planet stops being breathable roughly a billion years before it stops being wet. There is a long stretch at the end where Earth still has oceans, still has weather, still has a blue sky from orbit, and nothing on it can use any of that. One thing first, if you want more nights like this, subscribe. That's all I'll ask. Back to it. That gap is the thing that changed. It is not that the deadline moved, it is that there turns out to be a second deadline, earlier, that nobody had put a number on. Now think about what a billion years is against what has already happened here. Animals have existed for about 600 million years. Everything you would recognize as an animal, everything with a body and a mouth and a way of moving, fits inside that. Land plants are younger, around 470 million. Anything you could call a person is a rounding error at the end of it. So the future for complex life on this world is longer than its past, roughly twice as long. That sounds like reassurance, and it is the opposite, because it means we are not near the beginning of anything. We are somewhere in the middle of a run that has a stated end. And there is a harder version of that, which is that the end is not gradual. You would expect a planet to wind down, oxygen slowly falling, animals slowly getting smaller, forests slowly thinning, over tens of millions of years, everything having time to adjust. That is not what the model produces. What it produces is a long period where almost nothing changes, and then a fast collapse at the end of it. The air holds and holds and holds, and then it does not. We will spend proper time on how fast, because it is the most surprising thing in this entire subject, and it is not what anybody assumes. Before that, it is worth being clear about what is actually being claimed, because it is easy to hear this as a prediction, and it is not quite one. Nobody is saying this is what will happen on a Tuesday 1.08 billion years from now. What the model says is that under the physics we can see, with the sun behaving the way stars of its type behave, an oxygen-rich atmosphere on this planet has a lifespan, and the lifespan is around 1 billion more years. The error bars are 140 million years wide. That is not a small window. It is longer than the entire history of dinosaurs, front to back, sitting inside the uncertainty of a single number, which tells you something about the kind of question this is. It is precise enough to be worth stating, and loose enough that arguing about the third decimal place would be silly. There is also a competing figure, published more recently, that pushes things considerably further out. We are going to give that a fair hearing tonight, because the honest position is not that this is settled, but the direction is not in dispute. Every model anybody has built agrees on the shape. Oxygen is not a permanent feature of this planet. It has a beginning we can date, and it has an end that follows from the behavior of an ordinary star. Here is the part of the paper that I keep coming back to. They did not set out to write about the end of anything. Ozaki and Reinhard study how living things and rocks and air trade material back and forth over enormous stretches of time. The question they were really chasing was about other planets, and we will get to that at the end of the night, because it is the largest thing in this whole subject. The billion-year figure came out sideways, as a consequence of asking something else, which is how most of the useful numbers in this field have arrived. Now, a thing worth noticing about your own reaction to that number. Almost nobody hears 1 billion years and feels anything. It is too large. The mind flattens it into never, files it next to the heat death of the universe, and moves on. That flattening is doing something, and it is worth knowing that it is doing it, because the same mind that files 1 billion years under never also holds, without ever having examined it, the assumption that this planet is fundamentally a place that supports breathing, that the air is what Earth is like, that the oxygen is a property of the world rather than an event in its history. That assumption is wrong, and it is wrong in both directions. It was wrong about the past, because for more than half of this planet's existence there was effectively no oxygen at all, and everything that lived here lived without it and did fine. What Earth is actually like, taken across its whole life, is a world without free oxygen in its air. The breathable version is the exception. We happen to be inside the exception, which makes it feel like the rule. There is a number that puts that plainly. This planet is about 4.5 billion years old. Oxygen has been a meaningful part of the atmosphere for roughly the last 2.4 billion of those, and at the level you are breathing for far less than that. Add another billion years of breathable time on the end, and then a long stretch afterward with none. Run those numbers however you like and you get the same result. The air you have is a phase. It is not the default, and it is closer to its end than to its start. That is the claim tonight, and every part of it is measurable except the exact date. What we are going to do from here is take it apart in the order that matters. First, how fast the collapse actually runs, because the answer is not on a geological timescale in the way you would expect. Then what suffocates, and in what order, which is the part nobody writes down. Then what the air turns into afterward, which is a place, and a place a camera could stand in. Then the thing that survives all of it, which has been here the whole time and is not going anywhere. And then, only then, the reason. Because the reason is a star doing something completely ordinary, and it helps to know what is at stake before you look at the mechanism that does it. Before that, it helps to have something physical to hang 1 billion years on, because the number does not mean anything on its own. Here is one. This solar system goes around the center of the galaxy once every 230 million years or so. It has done that about 20 times since it formed. In the time this planet has left as a breathable world, it gets around 4.5 more times. 4.5 laps, that is the whole remaining supply. Here is another, and it is closer to home. The continents move. They are moving right now, at roughly the rate your fingernails grow, and over hundreds of millions of years, that adds up to entire oceans opening and closing. The continents have gathered into a single mass and broken apart again several times. The last time was around 300 million years ago. They are expected to do it again within the next few 100 million years, and then very likely once more after that. So in the time remaining, this planet assembles all its land into one continent, tears it apart, and quite possibly does the whole thing over. The map is rewritten completely, twice, and there is still time left afterward, before the air fails. That is the scale. Not a countdown anybody experiences, a stretch long enough for the surface of this world to be redrawn from scratch more than once. And here is the one that I think lands hardest. Take everything that has ever happened on this planet, involving anything with a body. Every animal, every forest, every ocean full of things swimming, the entire fossil record from the first shell to the present day. That is about 600 million years. Now double it and add a little. That is what is left. Which means, if you take the whole history of complex life on this world as a single object, we are somewhere around a third of the way through it. Not near the end, not near the beginning. Somewhere in the middle of a run with a stated finish. That is either a comfort or the opposite, and I have not been able to decide which. What it definitely is not is unlimited, which is the thing almost everybody assumes without ever putting it into words, and the assumption does not survive contact with a single published number. There is one more thing worth saying about the paper before moving on, and it concerns how careful it is. Ozaki and Reinhard did not run one simulation and publish the answer. They ran the model over 400,000 times precisely because they could not know the correct inputs, and the spread of results is the actual product. The 1.08 billion figure is where the distribution peaks, not a single calculation anybody has confidence in on its own. That is a more honest way of handling a question this far out than anybody usually manages, and it is worth noticing that they built the uncertainty into the method rather than adding it to the end as a caveat. Almost nothing about the deep future gets treated that carefully. Most of what circulates is one calculation with a large number attached, repeated until it sounds established. This is not that. This is hundreds of thousands of runs of a whole planet, and what came out the other side was a lifespan. Start with speed, because everybody assumes the end of a world is slow, and this one is not. The collapse itself takes about 10,000 years, and that is the number in this whole subject that nobody is ready for. Not 10 million, not a slow decline across an era, with forests thinning over tens of millions of years and everything having room to adjust. About 10,000 years, from an atmosphere you could breathe to one you could not. Put that against the thing you already know. The last ice age ended 11,700 years ago. That is when the glaciers pulled back off the northern continents, and the sea came up, and the land you live on became the land you live on. Everything since then is inside that window. All farming, every city anybody has built, writing, which is about 5,000 years old, every war, every language, every person you have ever heard of. The entire loss of Earth's oxygen fits inside a stretch about that long. If you had been standing here at the start of it, you would not have noticed anything. If you had come back at the end, you would be dead within minutes. That is the thing that separates this from every other slow ending anybody talks about. The sun swelling, the oceans boiling, the continents grinding into each other. All of those take hundreds of millions of years, and everything alive has time to become something else. This one does not give that. Here is why it runs fast, and it comes down to what oxygen actually is in this atmosphere. Oxygen is not stored here, it is produced. Every molecule of it in the air above you was put there by something alive, and it is only up there because the production keeps running. Left alone, oxygen does not stay. It is one of the most reactive things there is. It attacks iron, it attacks rock, it attacks anything organic. It burns whatever it can reach. The reason there is any in the sky at all is that plants and algae and bacteria are pushing it up faster than the planet can eat it. Take away the pushing and the eating carries on. That is the whole of it. So the question is never whether the oxygen holds. The question is only whether the thing making it is still running. And what the model shows is that the thing making it does not wind down gently. It hits a wall. Photosynthesis needs carbon dioxide. Below a certain amount there is not enough to work with, and the process stops. Not slows, stops. It is a threshold, and on one side of it plants live, and on the other side they do not, and the planet walks across that line at a steady pace and then crosses it. Once it is crossed, the production ends across the whole world at roughly the same time, because the whole world shares one atmosphere. Then the oxygen just gets used up by an ordinary planet doing ordinary chemistry. Rocks take some, volcanic gases take some, everything that has ever rusted takes some, and it comes down. There is a second thing that makes it faster than it would otherwise be, and it is the one that turns a decline into a collapse. The ozone layer is made of oxygen. That is all it is. Oxygen rearranged by sunlight high in the atmosphere. It is the only reason the ultraviolet coming off the sun does not reach the ground at full strength. As the oxygen falls, the ozone goes with it. As the ozone goes, more ultraviolet gets through. And ultraviolet is very good at destroying the exact organisms that were still producing what oxygen was left. So the fall feeds itself. Less oxygen means less shielding, means more damage, means less oxygen. Once that starts turning, and there is nothing in the system that pushes back, that is what a collapse is, as opposed to a decline. A decline is a slope, a collapse is a slope that has started helping. Now compare the speed of the loss with the speed of the arrival, because the difference is not small. Oxygen took something like 200 to 300 million years to build up in the first place, and then sat almost unchanged for well over 1 billion years after that before it got anywhere near modern levels. 2 billion years roughly, from the first free oxygen to air you could actually use. 2 billion years to arrive, 10,000 years to leave. That is a ratio of something like 200,000 to 1. Whatever this planet spent building, it can lose in a blink of the same clock. There is a general lesson in there, and it is not only about oxygen. Things that take a very long time to assemble almost never take a comparably long time to come apart. The building requires everything to go right in sequence. The unbuilding only requires one thing to stop, which brings up the question anybody would ask next. And it is the right question. Could anything alive adapt in 10,000 years? For most of what you would think of as alive, the answer is no, and the reason is arithmetic. Adapting to no oxygen is not a small adjustment. It is a change to how a body gets energy at the most basic level, the part that has not been rewritten in any animal lineage for around 600 million years. Every animal on this planet runs on the same trick, which is burning food with oxygen inside cells, and every animal inherited it from the same ancestor. Rewriting that would take an enormous number of generations, and large animals do not have many. A generation for an elephant is decades. For a human, it is decades. Even for something small and fast, 10,000 years is a few thousand generations at best. Nothing rebuilds its core metabolism in a few thousand generations. It has never happened. The one time this planet produced a fundamentally new way of running a cell, it took hundreds of millions of years, and it happened once. So the animals do not get out of this by changing. There is no version where something adapts in time. Bacteria are a different story entirely, and we will come back to them, because they are the ones still standing at the end of this. Some of them divide every 20 minutes. In 10,000 years, that is 250 million generations, which is more chances than every animal that has ever lived has had put together. And more importantly, most of them never gave up the old way of living. They can already do this. They do not have to adapt, because they never stopped being able to survive without oxygen in the first place. That is the asymmetry at the heart of tonight. The thing coming is not new, it is a return. And the organisms that were here before oxygen kept the equipment. There is one more thing about the speed worth naming, because it changes how you should think about the number. 10,000 years is short in geological terms, but it is not short from inside. It is not an event anybody would experience as an event. If there was something here with a life like yours, watching it happen, nothing would look wrong for centuries at a stretch. The sky would still be blue, the oceans would still be there. Somebody's whole life could pass inside that window without a single alarming day. The change would be visible only across dozens of lifetimes, in records nobody was keeping for that reason, which is a strange kind of ending, not a catastrophe with a date, a slope steep enough to be fatal and shallow enough that no individual moment on it looks like anything. That is worth holding on to, because it is the honest picture, not a sky going dark, not a sudden loss, just a planet quietly returning to a condition it held for most of its existence, at a pace that would look like nothing at all from the ground. And then, at the end of it, a world with an atmosphere and an ocean and weather and no animals. There is a comparison that makes the speed concrete, and it comes from something that already happened. About 252 million years ago, this planet came closer to sterilizing itself than at any other point in the record. Enormous volcanic eruptions in what is now Siberia ran for hundreds of thousands of years, and the oceans lost their oxygen, and roughly 96% of everything living in the sea died. That is the largest extinction in the history of this world. It is sometimes called the Great Dying, and the name is not an exaggeration. The part relevant to tonight is how long the killing took. The current estimates put the main pulse at something on the order of tens of thousands of years. Some of the sharper phases may have run faster than that, so there is precedent. This planet has already run a low oxygen ocean event at roughly the speed the model predicts for the atmosphere, and the result was that almost nothing survived it. The difference is that the Great Dying ended. The volcanoes stopped, the carbon cycle rebalanced, the oxygen came back, and within a few million years, the oceans were filling up again with new things. The event in question tonight does not end. There is no phase afterward where conditions improve. Now, a fair objection, and it deserves an answer. You could reasonably say that 10,000 years is a wide range, and that the actual figure depends heavily on assumptions inside a model of a planet a billion years from now, and that nobody should take a specific number seriously at that distance. That is correct, and I would not defend the precision. The papers themselves describe the transition as rapid on geological timescales rather than putting a hard figure on it, and the range across different runs is considerable. What is not in dispute is the shape. Every version of this produces a long flat stretch followed by a fast drop rather than a gradual slope. That comes out of the structure of the system rather than out of the particular numbers fed into it, which is why it survives across the whole spread of runs. So the honest version is, the collapse is fast, faster than intuition allows for, and probably measured in thousands to tens of thousands of years rather than in millions, which is still short enough that nothing with a body gets out of it. And there is a broader thing about thresholds that is worth taking away from this, even if you never think about oxygen again. Systems that look stable for a very long time are not necessarily stable. Some of them are simply not yet at the edge. The stability you observe is not evidence of a wide margin. It is evidence that you have not reached the margin. And those are different facts that look identical from inside. This planet has held a breathable atmosphere for hundreds of millions of years without visible variation, which makes it feel like an extremely robust arrangement. It is not robust. It is a system sitting on one side of a line, and the line is not moving, and the planet is, which raises the question of who goes first, and the order turns out to be specific. Almost nothing on this planet dies of suffocation. Almost everything dies of hunger first, and that ordering is the part that never gets said out loud. Here is why. The oxygen does not fail on its own. It fails because the plants fail. The plants are the machine that makes it, and the machine stops before the supply runs down, because there is a lag between the two. So the first thing that happens is not thin air. The first thing that happens is that the green goes. Grass, trees, every crop anybody has ever grown. the algae in the top few feet of every ocean, which is quietly responsible for something close to half of all the oxygen produced on this world, and which almost nobody thinks about. All of it runs on the same input, and the input goes away. Everything that eats plants dies next, and that is most of what walks around. Then everything that eats those, it moves up through the whole structure in a matter of years, not centuries, because nothing that size carries more than a season of reserves. The air is still perfectly breathable while all of this is happening. That is the strange part. For the first stretch of it, you could stand outside and take a completely normal breath in a world where nothing is growing. The suffocation comes later, and it comes for what is left. Now the thresholds, because your own body has specific numbers attached to it, and they are closer than you would guess. You are breathing air that is about 21% oxygen. Take it down to 19.5%, and industrial safety rules already call that a deficient atmosphere and require breathing equipment. That is a drop of 1.5 points. At around 16%, judgment goes. Not consciousness, judgment. People at that level make bad decisions confidently and do not notice they are doing it, which is why it kills people in confined spaces so reliably. Around 12 to 14%, everything gets hard. Breathing is fast and shallow, thinking is slow, coordination goes. At 10%, people lose consciousness in minutes. At 6%, death follows in minutes. So the whole survivable range, from completely normal to fatal, is about 15 percentage points. That is the entire margin your species has, and it is the same margin every animal here has, give or take. For a sense of what a small change feels like, the summit of the highest mountain on this planet has roughly 1/3 of the oxygen pressure of sea level. People do reach it without bottled air. Very few, at enormous cost for a few hours, after months of preparation, and the human body begins dying the entire time it is up there. It cannot digest properly. It burns muscle. Nobody survives extended time at that altitude. That is 1/3. The collapse in question does not go to 1/3. It goes to something like 1/millionth. Now the order among the animals, which is not random. The ocean goes first, and it goes worst. And the reason is that water is a bad place to keep oxygen. Air is 21% oxygen. Seawater, at its best, holds a tiny fraction of that in dissolved form. Everything with gills is already living on a much thinner margin than everything with lungs, and it always has been. Worse, warm water holds less. That is straightforward physics, and you can watch it happen in a pan on a stove. So a warming planet strips oxygen out of its oceans before it strips it out of its sky. This is not speculative. There are places in the ocean right now where the dissolved oxygen has fallen far enough that nothing with a spine can live in them. There is one that forms every summer in the Gulf of Mexico. Thousands of square miles of water with a floor covered in nothing. Fish leave. What cannot leave dies. Those exist for local reasons, and they are small, and they come and go with the season. But they are the same process, and they show you what it looks like. On land, the order runs by size and by breathing apparatus. Insects are more exposed than you would expect, because insects do not have lungs. Air reaches their tissues by diffusing down a system of tubes, and diffusion only carries so far. That is why insects are small. It has not always been that way. About 300 million years ago, the atmosphere here held far more oxygen than it does now, possibly over 30%, and the insects of that period were enormous. There were dragonflies with wingspans around 2.5 feet, millipedes longer than a person is tall. When the oxygen came down, they came down with it. Insect body size tracks oxygen availability, and it has for hundreds of millions of years, and that relationship runs in both directions, which means the insects tell you where the atmosphere is before anything else does. They get smaller first, then they stop. Among the large animals, the ones with the most efficient lungs last longest, and the best in the world belong to birds. Birds do not breathe the way you do. Air runs through their lungs in one direction rather than in and out, which means fresh air is passing over the exchange surface continuously instead of mixing with stale air on every breath. It is a better design, and it is why birds can do things no mammal can. There is a goose that migrates over the highest mountains on Earth, crossing at altitudes above 20,000 feet, flapping the entire way, in air that would put an unacclimated person unconscious. It is the best performance any vertebrate has at low oxygen. It still has a flaw. It is just a lower one. Everything has a flaw, and below all of these flaws, the whole architecture goes at once, because every animal on this planet is running the same underlying process. That is the thing worth understanding about how total this is. There is no animal anywhere that has an alternative. Not one lineage that kept a backup. Every animal, from a sponge to a whale to you, gets its energy by combining food with oxygen inside its cells, using machinery inherited from a single ancestor around 2 billion years ago. Some can hold their breath a long time. Some can survive brief periods without it. Certain parasites and a few odd creatures in low oxygen sediment have partial workarounds, and there is a handful of tiny organisms that appear to have given up oxygen entirely. But there is no large animal with a second option. The entire kingdom is standing on one mechanism, and that mechanism has a fuel supply, and the fuel supply is running out on a schedule. Now the part that I think is the honest center of this whole section. None of it is violent. There is no moment. Nothing catches fire. Nothing explodes. No sky turns a color. It is a slow subtraction, spread across a stretch of time long enough that no single generation of anything would be able to tell. Animals get quieter, then rarer, then smaller. Then the large ones are gone, and the small ones are still there. And then the small ones are gone too, and the last of it happens in the ocean sediment, where nobody would have been watching anyway. At the end of it, this planet still has weather. It still has an ocean, and rain and seasons and a sky. It still turns on its axis at the same rate. From a distance, it would look almost exactly the way it looks now. It is simply that nothing on it is breathing. There is a group worth pulling out separately, because they are the last large things standing, and it is not who you would expect. Not the biggest animals, not the smartest, the ones that already live at the edge. There are fish in oxygen-poor water at the bottom of certain lakes that get by on almost nothing. There are worms in ocean sediment that spend their entire lives in mud with no oxygen in it at all, running on chemistry that most animals abandoned long ago. There is a group of tiny creatures found in deep basins in the Mediterranean that appear to complete their whole life cycle without oxygen, which was a genuine surprise when it was reported and is still argued over. None of those are going to inherit anything. They are small, they are specialized, and they are hanging on in conditions that happen to resemble the future. But they are the proof that the line is not perfectly sharp. There is a fringe of animal life adapted to almost no oxygen, and that fringe gets a little longer than everything else. It is a stay of execution measured against a planet, which is to say, it is nothing at all. Now, the thing about all of this that I find genuinely difficult, and I am going to say it plainly rather than dress it up, there is no suffering in the version of this that the model describes, and that is not a comfort. It is the strangest part. Populations do not experience their own decline. Individual animals live ordinary lives, find food or do not, raise young or do not, and die of ordinary causes, the same as they always have. Every one of them is doing fine on the day it is alive. The decline is a statistical property visible only across enormous stretches of time, to somebody counting, and there is nobody counting. So there is no scene, no last herd, no final animal aware of being the final animal. Just a long thinning across a period so extended that at no point does any living thing on the planet have information that anything is wrong. Which is how almost every extinction in the record actually went, including most of the big ones. The dramatic version, with a specific bad day, is a rare exception, and it took an asteroid to produce it. The ordinary way a category of life ends is that the conditions it needed slowly stopped being there, and nothing noticed. And there is one more piece of order worth stating. because it inverts what most people expect about who is fragile. The organisms with the highest oxygen demand relative to their needs are not the biggest. They are the most active. Anything that flies, anything with a high body temperature that has to be maintained, anything with a large brain, because nervous tissue is the most oxygen-hungry material any animal builds. Your own brain is about 2% of your body weight and consumes something like a fifth of the oxygen you take in. That ratio is extreme, and it is the price of thinking, which means that in a declining atmosphere, the traits that go first are the expensive ones: flight, warm blood, big nervous systems. The last complex things standing would be slow, cold, small and simple. Everything this planet spent 600 million years building on top of that gets unbuilt in the opposite order it was built in. Which raises the next question: if the air is not oxygen anymore, what is it? And the answer is that it becomes a place with a name and a history. The air that replaces this one is mostly the same air. Start there, because almost everybody pictures it wrong. You are not breathing an oxygen atmosphere. You are breathing a nitrogen atmosphere with some oxygen in it. Nitrogen is 78% of what goes into your lungs, and it does nothing at all for you. It is simply there, and it stays there, and nothing in this story removes it. So the future atmosphere of this planet is still about 4/5 nitrogen, still roughly the same pressure, still thick enough for wind and weather and clouds and rain. One ingredient goes missing. That is the entire change. What fills the space is methane, and there is going to be a great deal of it. The model puts methane at something like 10,000 times current levels. Right now it is a trace gas, measured in parts per million, and it matters mostly because it traps heat. In the atmosphere that follows, it is a major component. Methane is there for a simple reason. It is what living things produce when they break down organic material without oxygen. Right now, that happens in swamp mud and ocean sediment and the guts of animals, in the pockets of this world where oxygen does not reach, and the methane that escapes gets destroyed in the open air within about a decade. Take the oxygen out, and nothing destroys it. It accumulates. So the sky above this planet gets written by the organisms living in the mud, which is a reversal worth sitting with. The things that have spent 2 billion years confined to the low places end up setting the composition of the whole atmosphere again. Now the ozone, and this is the change with teeth. There is no ozone layer in the atmosphere that follows. There cannot be. Ozone is made of oxygen and nothing else, assembled high above the ground by sunlight breaking oxygen apart and putting it back together in a different arrangement. No oxygen, no ozone. It is not a matter of degree, which means ultraviolet arrives at the ground at full strength. Ultraviolet damages the molecules that carry genetic information. That is not an exotic effect, it is the ordinary one, and it is why sunlight burns skin on a planet that does have an ozone layer. Remove the layer entirely, and the surface becomes a place where nothing exposed can hold its own chemistry together. So the last habitable places are underwater and underground. Water blocks ultraviolet well. A few feet of it is enough. Rock blocks it completely. Everything that ends up surviving this ends up surviving it by being somewhere the light does not reach. Now the part almost nobody expects, and it is the opposite of what the phrase dying planet makes people picture. There is very little carbon dioxide in that atmosphere. Not a lot. Almost none. Everybody assumes a dead Earth is a hothouse choked with carbon dioxide, because that is the story we tell about ruining a planet. This is the reverse. The carbon dioxide is the thing that runs out first, and its running out is what kills the plants, and the dead plants are why the oxygen goes. The air at the end is hot and thin on carbon dioxide and full of methane, and has no oxygen and no ozone. It is not a version of anything anybody has warned about. It is an older arrangement coming back, and there is a good chance it is not clear. When you have a lot of methane and a lot of ultraviolet and no ozone to intercept it, the ultraviolet starts breaking the methane apart, and the pieces stick together into larger molecules. Those molecules do not stay dissolved in the air, they form a haze. There is a place in this solar system where you can watch that happening right now. Titan, the largest moon of Saturn, has a thick nitrogen atmosphere with methane in it, and the whole thing is wrapped in an orange organic smog, so dense that for decades nobody could see the surface at all. Voyager flew past and photographed a featureless orange ball. That haze is made by exactly this process: ultraviolet, methane, no oxygen. Nobody is claiming this planet ends up looking like Titan. It is warmer, it has oceans, and the chemistry is not identical. But the same reaction runs under the same conditions, and there is reasonable argument that early Earth had a haze of its own for the same reason before oxygen arrived. So the honest picture is a sky that is probably not blue. Hazier, likely tending orange, with the sun a dimmer and redder thing seen through it, on a planet that is receiving more energy than it does now. The oceans are still there. That part does not change for a long time afterward. They are just not oceans anybody would recognize. Water holds far less dissolved oxygen than air does even at the best of times, so the oceans lose theirs early and completely. What fills anoxic water is sulfur chemistry, and sulfur chemistry has a smell and a color. The organisms that thrive in it are not colorless. There are bacteria that make a living off sunlight and sulfur instead of sunlight and water, and they come in deep purple and deep green, and where they bloom in oxygen-free water today, they turn it those colors visibly. There are lakes on this planet right now where you can see it, water with no oxygen below a certain depth, and a layer of purple where the light and the sulfur meet. Whether that becomes the standard appearance of the ocean is not something anybody can state with confidence, and I am not going to pretend otherwise. But the conditions that produce it become the normal conditions. Now step back and look at the whole thing from outside, because this is the version that matters most for the last part of tonight. From orbit, this planet still looks like a planet with an ocean. Blue in places, white with cloud, brown where there is land, turning once a day, with storms and seasons. What it does not have is green. That is the single most visible difference. Everything green on the surface of this world is a thing that runs on carbon dioxide, and that is what goes first. And it does not have an oxygen line in its spectrum. Which is to say, if somebody with a good enough telescope were looking at this world from another star at that time, they would find an atmosphere, and weather, and water, and they would find no sign whatsoever that anything was alive on it. They would be wrong. There would be an enormous amount alive on it. They would simply be looking for the wrong thing. And we are going to come back to that at the end, because it is the largest consequence in this entire subject, and it is the reason the paper got written in the first place. There is a place you can go and look at that ocean right now, and it is not obscure. The Black Sea is the largest body of oxygen-free water on this planet. Below about 500 feet down, there is no oxygen in it at all, and there has not been for thousands of years. That layer holds something like 90% of the total volume of the sea. What lives down there is sulfur chemistry and the bacteria that run on it. What does not live down there is anything with a spine, anything with gills, anything you would recognize. It is that way because of geography. Fresh water comes in from rivers at the top, heavy salt water comes in from the Mediterranean at the bottom, and the two layers do not mix. So the deep water never gets refreshed, and whatever oxygen it had was used up long ago. The effect on anything that falls into it is unusual. Wood does not rot properly without oxygen, and neither do the organisms that would normally do the rotting. Ships that sank into that layer have been found on the bottom with their masts still standing and their rigging still attached, after more than 1,000 years. That is what an anoxic ocean does. It stops taking things apart. So the future ocean is not empty, and it is not still. It is a working system with its own chemistry and its own organisms, doing things at scale. It simply has nothing in it that breathes. Now the surface, which is the part hardest to picture accurately, and I want to be careful about what is known and what is not. The continents are not sand. This is not a desert planet. There is still rain, because there is still an ocean and there is still a sun to evaporate it, and the water cycle does not care whether anything is alive. So there is weather, storms, seasons, rivers running to the sea, snow on high ground in some places. What there is not is soil in the sense you would recognize. Soil is largely a biological product. Take away the plants and the roots and the things that live in it, and what is left is broken rock and dust, held together by nothing, moved around by wind and water with no vegetation to slow it. The rivers would run brown. The coastlines would move constantly. Nothing would be holding anything in place. There is one more feature of that world worth naming, and it is the one that would strike anybody standing on it hardest. It would be quiet. Every sound on this planet that is not weather is made by something alive. Birds, insects, animals moving through vegetation, the enormous background noise of the ocean, which is largely biological. Take all of that out, and what remains is wind, water and rock, and nothing else, permanently. That is not a scientific point, and I am including it anyway, because it is the accurate one. A world with an atmosphere and an ocean and weather and no sound in it except the weather. For now, the question standing is, what is actually still living down there, under the haze, in the water, in the rock? And the answer is that it is the oldest thing on this planet, and it never went anywhere. The things that survived this were here first, and for them it is not a catastrophe, it is a homecoming. They are microbes, and they never needed oxygen, and a great many of them cannot tolerate it. To those organisms, the air you are breathing right now is a poison they have spent 2 billion years hiding from. That is not a figure of speech. Oxygen is chemically aggressive. It tears apart the machinery inside cells that were not built to handle it. The reason those organisms are confined today to mud and sediment and rock and the insides of animals is that the rest of the planet became lethal to them, and they retreated to the parts that did not. They are still there, all of them, in enormous quantity. Start with where they live, because the locations are ordinary and you could visit most of them. There is the mud at the bottom of any pond you have ever stood beside, an inch or two down, where the oxygen stops reaching. There is waterlogged ground in any marsh you have walked past. There is the sediment under every ocean, a continuous layer of oxygen-free material covering most of the surface of your world. There is the inside of a cow, which makes methane for exactly this reason. There is a version of it inside you, and there is the rock itself. Underneath the continents and underneath the seafloor there is a biosphere living inside solid stone, in the water held in cracks and pores, going down for miles. Cells have been pulled up from sediment far below the ocean floor that appear to have been sitting there for millions of years, dividing perhaps once a century, running so slowly that it is a genuine question whether the word alive is being used the same way. Estimates of how much life is down there vary a lot, and the honest range is wide, but every serious attempt puts it at a very large share of all the living material on this planet, possibly comparable to everything on the surface, possibly more. None of that depends on the sky, which is the first thing worth understanding about how this ends. The deep biosphere does not notice. It has no relationship with the atmosphere at all. Whatever happens to the air, it carries on exactly as it has been doing, at the same unhurried pace, for as long as there is heat in the rock and water in the cracks. Now the ones nearer the surface, because those are the ones that inherit the visible world. There are organisms that do photosynthesis without producing oxygen. They came first, and they still exist, and they work by using something other than water as their raw material, usually a sulfur compound, light in, energy out, and the waste product is sulfur rather than oxygen. Those are the purple and green bacteria. They live in oxygen-free water, where light still reaches, which today means a narrow band in certain lakes and springs and lagoons and a few places in the ocean. In the atmosphere that follows, that narrow band becomes most of the water on the planet. And there are the methane makers, which are not bacteria at all, but a separate branch of life entirely, as distinct from bacteria as you are. They take simple molecules and produce methane, and they have been doing it for something like 3.5 billion years. And they are the reason there is any methane on this world at all. They are also the ones that write the sky at the end. The methane that fills that atmosphere comes out of them. The organisms that got pushed into the mud by oxygen end up determining what the whole planet looks like from space. Here is the part that carries the real weight, and it is not the survival, it is the ceiling. Nothing like you ever comes back. That is not a guess. It is the clearest pattern in the whole history of life here, and the reason is energy. Burning food with oxygen, which is what your body is doing right now, releases a great deal more energy than any of the alternatives. Not a little more. Something like 15 times more out of the same material. Every other way of making a living that life has invented, and it has invented many, returns a fraction of that. Your body is expensive. Your muscles are expensive. Your brain is the most expensive tissue anything on this planet has ever built, and it is running on that 15 times. None of it is affordable on the low-yield chemistry, so none of it gets built, which is why, across roughly 2 billion years of life on this world without oxygen, nothing ever got bigger than a mat. It was not for lack of time. 2 billion years is the entire history of animals several times over. It was not for lack of invention, because those organisms worked out nearly every chemical trick life has ever used. They simply could not pay for a body, so nothing ever had one. Then oxygen arrived, and within a geologically short span afterward, there were animals. So the sequence runs one way. No oxygen means no complexity. Add oxygen, and complexity follows. Take the oxygen away again, and the ceiling comes back down. And this time, there is no route back up. And that is the difference between this ending and every other bad thing that has happened to this planet. Every mass extinction in the record was survivable in the long run. The asteroid, the volcanic episodes, the ice ages, the ocean anoxia events. Each one killed an enormous share of what was living, and each one was followed, within a few million years, by recovery. Because the conditions came back. The dust settled, the carbon cycle rebalanced, the world returned to something like what it had been, and life refilled it. This one does not have that. The cause is not an event. The cause is a star that is getting steadily hotter and will not stop, and every year afterward is worse than the year before it by exactly the same small amount. There is no settling. There is no rebalancing. There is nothing to recover into. So what this planet ends up with is a biosphere that is genuinely alive, genuinely widespread, arguably enormous in total mass, and permanently incapable of ever being anything more than it is. It goes on for a long time in that state, probably a very long time. The microbes are not in a hurry, and the conditions they need are the conditions the planet is heading toward anyway. But everything with a body ends, and does not return, and the whole 4 billion year project of getting from a cell to something that could look up ends up having been a phase in the middle rather than a direction. That is the honest shape of it, and I do not think there is a comforting way to say it. There is one thing that softens it slightly, and it is worth having. The complexity happened. Whatever else is true, this planet did produce something that could measure its own atmosphere, calculate when that atmosphere ends, and publish the number. That is a real event that occurred, and the ending does not reach backward and undo it, which is a smaller consolation than most people want, and it is the only one available. There is a category of survivor I have not mentioned, and it is the one least dependent on any of this. At the bottom of the ocean, there are places where hot water comes up out of the seafloor, loaded with dissolved minerals, and where it meets the cold water it builds chimneys of rock and supports entire communities of living things. Those communities do not run on sunlight, they run on the chemistry of the water coming out of the ground. The energy source is the interior of the planet rather than the star. They are usually described as exceptions, and they are not, particularly. There is a serious argument that this is where life on this world began, and that everything on the surface is the branch that left. Whatever happens to the atmosphere, whatever happens to the sun, those systems keep operating. Their fuel is the heat of a planet cooling from its formation, and that has billions of years left in it regardless of what the sky is doing. So there is a flaw under all of this. Not a comfortable one, but a real one. The last living things on Earth are probably going to be sitting around vents in the dark, running on the same chemistry they were running on 4 billion years ago. entirely indifferent to everything that happened in between. Now the honest counter-argument to the ceiling, because there is one, and it deserves airtime. I said complexity never comes back, and the basis for that is that low-yield chemistry cannot pay for large bodies. That is well established, and it is the mainstream position. But there is a fair objection. 2 billion years without oxygen produced nothing large, and it is not completely certain that the energy budget is the whole reason. Other things were different about that period too. There is argument about whether the crucial step was actually the availability of oxygen or the specific merger of one cell into another that made complex cells possible, which happened once and might simply be very unlikely regardless of the atmosphere. If that is right, then the ceiling is not purely about energy, and the honest thing to say is that we have one example and cannot fully separate the causes. It does not change the practical answer. Whatever the reason, the record shows 2 billion years of no complexity without oxygen, and there is no case of anything large arising in low oxygen conditions anywhere in the fossil record. That is the evidence available, and it points one way. There is a last thing about the survivors that I think reframes the whole picture, and it is a matter of counting. If you measure life on this planet by mass, plants win by an enormous margin, mostly because of trees. If you measure it by number of individual organisms, bacteria win by a margin so large the plants do not register. If you measure it by total time, by how many organism years have been lived on this world, the microbes win again, and it is not close, because they have been here for the whole 4 billion years, and everything else arrived late. By almost any measure except the one we naturally use, this has always been a microbial planet with a brief and unusual decoration on top. The decoration is what we are, and what everything we care about is, and it is genuinely remarkable that it happened at all. It is also, by the numbers, the exception. And what tonight describes is not the planet dying. It is the planet returning to what it has been for most of its existence, and what it will be for most of the rest. And it raises an obvious question. If oxygen is a phase, then it started. So it is worth asking exactly when it started, and whether anything was watching, because the answer is written into rock you can go and stand in front of. Oxygen arrived on this planet about 2.4 billion years ago, and there is rock you can walk up to and put your hand on that recorded it happening. The rock is striped, bands of dark iron alternating with bands of red, laid down in layers, sometimes for hundreds of feet without a break. There are formations like this in Australia, in Canada, in South Africa, in Minnesota. They are among the most common ancient rocks on the surface of this world. They exist because of what oxygen does when it meets iron. The early oceans held an enormous amount of dissolved iron. That is possible only in water with no oxygen in it, which is what the water was. Then something started producing oxygen, and the oxygen found the iron, and the iron rusted and fell out of solution and settled on the seafloor. Layer after layer, for hundreds of millions of years, until the oceans ran out of iron to take it out. Almost all the iron ore anybody has ever mined comes from those layers, which means the steel in every building you have been inside, every car, every ship, every bridge, was pulled out of the record of this planet, learning to make oxygen. We are standing on the receipt. Now the timing, and it is stranger than the simple story suggests. The organisms that made it were cyanobacteria, and they did not invent the trick at the moment the oxygen appeared. They invented it a long time before. Chemical traces in old seafloor sediments suggest oxygen-producing photosynthesis was running for hundreds of millions of years before the atmosphere showed any sign of it. So there is a gap, a very long one. Something was making oxygen, and the air stayed empty. The reason is that the planet ate all of it. Dissolved iron in the ocean, gases coming out of volcanoes, fresh rock exposed at the surface. All of it takes oxygen greedily, and for a very long stretch the production could not keep ahead of the consumption. Only when those sinks were filled did anything start accumulating in the air. That is the same relationship, running the other way, that ends this. Oxygen in the atmosphere is the difference between what is produced and what is consumed, and the consumption never stops. It took hundreds of millions of years of surplus to build a surplus. It takes only the loss of the production to erase one. Then when it did start accumulating, it killed almost everything. That is the part that gets left out. From the point of view of what was living here, the arrival of oxygen was the worst thing that had ever happened. The entire biosphere was made of organisms with no defense against it, and a highly reactive gas began filling every part of the world they lived in. Some of them died, some of them retreated into the sediment and the deep water and stayed there permanently, which is where their descendants are tonight. A few evolved ways of handling it, and then a few of those went further and learned to use it, and that turned out to be the most consequential thing that has ever happened on this planet. It is sometimes called the oxygen catastrophe, and the name is accurate. The biggest extinction event in the history of this world was caused by a waste product. Then nothing happened for a very long time. This is the part of the record that surprises people the most. After the oxygen arrived, it plateaued. It sat at a level well below what you breathe, and it stayed there, and the world stayed almost completely unchanged for something like 1.5 billion years. Geologists have a name for that stretch. They call it the boring billion, which is a rare piece of honesty in scientific naming. Nothing much evolved. The chemistry of the oceans barely moved. Whole eras passed with the planet in the same configuration, which is a longer period of stability than anything before or since. 1.5 billion years of a world with oxygen in the air and nothing on it more complicated than a mat of cells, which tells you that oxygen alone was not sufficient. It was necessary, and it was not enough, and something else had to change before anything got bigger. Then, somewhere between about 800 and 540 million years ago, the oxygen went up again. Not everywhere at once, and not smoothly, and the details are argued over hard, but it went up, and animals appear, not slowly. In the record, the gap between the second oxygen rise and the arrival of recognizable animal bodies is short. Soft-bodied things first, then things with hard parts, then within a relatively brief window almost every major body plan that exists today. Every animal group you can name traces back to that stretch. It is the single largest event in the history of complex life, and it sits right on top of the point where the oxygen went up. Nobody has proved the causal link to everybody's satisfaction, and there are researchers who argue the oxygen followed the animals rather than preceded them. That argument is live, and I am not going to pretend it is settled. But the pattern across the whole record is not subtle. Low oxygen, nothing large, for 2 billion years. Oxygen up, animals, within a geological blink. That has happened once, and it went in that order. Now put the whole staircase in front of you, because the shape of it is the point. No oxygen for the first 2 billion years. Then a rise, and a plateau that lasts 1.5 billion years with nothing complex on it. Then a second rise, and animals immediately. Then 500 million years of everything you have ever heard of, which is where you are standing. Then, 1 billion years from here, the whole staircase in reverse, and considerably faster going down than it was going up. That is what the record actually says. Not that oxygen is a feature of Earth. That oxygen is an episode with a beginning that is dated, and a middle that we are inside, and an end that follows from physics nobody disputes. There is a piece of honest uncertainty worth attaching to all of this. The dates move. The Great Oxidation Event is usually placed around 2.4 billion years ago, but the range in the literature spans several hundred million years, and work published as recently as last year is still revising why the delay lasted as long as it did. The second rise is argued about even more. None of that changes the sequence. It changes the exact numbers on the steps. And there is a thing about that whole history that I find more interesting than the dates. Every step on that staircase was caused by something alive. The oxygen did not come from geology. It came from organisms, in the water, doing something for their own reasons, with no capacity to know what they were doing to the planet. They rebuilt the atmosphere of an entire world, killed most of the existing biosphere, and made every animal that would ever exist possible, and the whole thing was a byproduct. That is the largest thing life has ever done here, and nothing involved in doing it had a nervous system. And it did something else on the way, which is the part of this history I find hardest to believe even though the evidence is solid. The arrival of oxygen froze the planet. Before it, the atmosphere held a lot of methane, and methane traps heat very effectively. It was doing a large share of the work keeping this world warm underneath a much dimmer sun. Oxygen destroys methane. That is straightforward chemistry, and it happens quickly. So when the oxygen came up, the methane went down, and the heat trapping went with it, and the temperature fell. Not slightly. There is evidence of glacial deposits from that period at low latitudes, which is to say ice at the equator, which is to say the entire planet. It is called the Huronian glaciation, and the estimates for how long it lasted run to something like 300 million years. Ice, everywhere, for longer than the entire history of dinosaurs and mammals combine. Set the sequence out plainly. Something alive invented a new way of feeding itself. The waste product poisoned most of the existing biosphere. Then the same waste product stripped out the gas that was keeping the planet warm and froze the world solid for 300 million years. And that same waste product is the reason you exist. The largest catastrophe in the history of this planet and the precondition for every animal that has ever lived are the same event. There is no way to separate them, and no version where you get one without the other, which is worth knowing whenever you hear anybody call a change to a planet's air good or bad. Those words do not survive a long enough time scale. What happened 2.4 billion years ago was an extinction, a frozen world, and the foundation of everything you are, all at once, and which of those you call it depends entirely on when you are standing. Now where you could go and see this, because these rocks are not hidden. The largest of them are in the Hamersley region of Western Australia, where the layers run for hundreds of feet across an enormous area. There are more around Lake Superior, in Minnesota and Michigan, which fed the steel industry of an entire country for a century. More in Brazil, in Ukraine, in South Africa. They are not rare and they are not subtle. They are among the most valuable rocks on this world, and the reason they exist is that your planet spent several 100 million years rusting its own oceans. You can stand in front of one and count the layers with your eye. Each band is a stretch of time when something alive was making oxygen. The whole face is a record of a world changing what it was, written by organisms that had no idea they were writing anything and no idea anybody would ever read it. That is the strongest thing in tonight, and it is not an argument. It is a rock face, and it tells you what every calculation tells you, which is that the air you breathe has a history, and history does not stop. Which brings us to why it ends, and the reason has nothing to do with anything alive. It is a star, far enough away that its light takes 8 minutes to get here, doing precisely what stars of its kind do. The sun is brighter today than it was when the dinosaurs were alive, and it is brighter now than it was when the first people were. Not by much. The rate is about 1% every 110 million years, which works out to roughly 10% per billion. Nothing anybody could feel across a lifetime, or across 1,000 lifetimes, or across the entire history of the species. But it does not pause, and it does not reverse, and it has been doing it without interruption since before this planet existed. When Earth formed, the sun was putting out roughly 70% of what it puts out now. That number causes a problem, and the problem is the best evidence anybody has that the brightening is real. At 70%, this planet should have been frozen solid. Not partly, completely, all the way to the equator, for its first 2 billion years. The arithmetic is not close, and it is not controversial, except the rocks say otherwise. There is evidence of liquid water on the surface of this world going back close to 4 billion years, which is nearly as far back as there is any rock at all to look at. Water that flowed, sediment that settled in it. There are even indications of what look like ancient raindrop impressions. So the sun was too dim for liquid water, and there was liquid water. 2 researchers named Carl Sagan and George Mullen laid that contradiction out in 1972, and it has been called the faint young sun problem ever since. The answer, as far as anybody can tell, is that the early atmosphere held far more carbon dioxide and methane than this one does, and the extra heat trapping made up the difference. Which is the crucial thing. This planet has stayed roughly comfortable for 4 billion years underneath a star that got 30% stronger, and it did that by steadily reducing the amount of heat its own air traps. The carbon dioxide has been coming down the whole time. Now, why the sun does this at all, and I will keep it to what actually matters. Stars run on hydrogen fusing into helium. 4 hydrogen atoms become 1 helium atom, which takes up less room. So as a star ages, the core slowly becomes denser, and a denser core is a hotter core, and a hotter core fuses faster. That is it. The sun gets brighter because it is running out of fuel. The exhaust builds up in the middle and squeezes what is left. Nothing about that is unusual, and nothing about it is going wrong. Every star of this kind does exactly this for its entire life, and the one you live under is a completely ordinary one, in the middle of its stable period, behaving normally. Which is worth being clear about, because it is not the ending you have heard about. The sun swelling into a red giant, swallowing Mercury and Venus, scorching this world down to bare rock, is a real thing that will happen. It is also about 5 billion years away, and it has nothing to do with what ends life here. What ends life here is the boring version, the steady one. The sun on its best behavior, doing nothing exceptional, just quietly turning up by a fraction of a percent every few tens of millions of years, forever, and taking your entire lineage with it on the way. There is a whole solar system worth of demonstration for what that does. Venus is closer in than we are, and it is roughly the same size, made of roughly the same material, and it very likely had water once. There is serious argument that it may have had oceans and stayed reasonably temperate for a long stretch, possibly billions of years. It is now hot enough at the surface to melt lead, with an atmosphere so heavy it would crush a person, and not a drop of water anywhere on it. The thing that did that was proximity to the same star. It sat slightly too close for slightly too long. Its water ended up in the atmosphere where sunlight broke it apart, the hydrogen escaped to space, and the ocean left permanently. That is the same process running on a shorter clock, not an exotic mechanism, just more of what this planet is already getting. Now the part that matters about all of this, which is that there is nothing to be done about it. Almost every threat you have ever heard anybody worry about has an intervention attached. An asteroid could be deflected, a disease could be treated, damage a world does to its own chemistry can, in principle, be repaired by whatever did it. The interior of a star is not somewhere anybody reaches. There is no version of this where somebody goes into the core of the sun and slows the helium down. The fuel supply and the geometry are what they are, and they will do what they do regardless of what is alive on any world nearby. The only ideas anybody has floated involve moving your planet instead of fixing the star. That is not entirely fantasy, and I want to be fair to it. There are published calculations on gradually shifting this world's orbit outward by repeatedly swinging large objects past it, borrowing a little orbital energy each time. The physics works. The scale is beyond anything anybody has the faintest idea how to attempt, and somebody would have to keep it up for hundreds of millions of years without a break. The recent work on how long the biosphere lasts explicitly mentions it as the one route that changes the answer. Set that aside and the picture is simple. The clock is a star. The star is fine. The star is going to keep being fine at increasing intensity for billions of years, and that is precisely the problem. There is a way of putting this that I keep returning to. Everything alive on this world exists inside a narrow band of conditions, and the band is not fixed in place. It is sliding. It has been sliding the entire time, slowly, in one direction, and life here has kept up with it by adjusting the composition of the air. That adjustment has a limit, because the way it works is by removing carbon dioxide, and there is a point past which there is not enough carbon dioxide left for anything to grow. There is something about the faint young sun that is worth pulling out on its own, because it changes how you should think about this planet's whole history. For 4 billion years, this world has been sitting under a star that was steadily strengthening, and the temperature at the surface has stayed inside the range where water is liquid the entire time. Not perfectly. There have been ice ages, and there have been much hotter periods. But it has never frozen permanently, and it has never boiled, across a span in which the energy arriving increased by roughly a third. That is not luck, and it is not a coincidence, and for a long time it looked like one. It is a control system. The carbon dioxide in the air has been coming down the whole time, at roughly the rate needed to offset the sun coming up, and the mechanism doing it is chemistry between rain and rock that has no awareness of anything, which means this planet has been running a thermostat for 4 billion years, and none of the components know they are part of one. That is the actual reason there is anything alive here, not distance from the sun, which was never going to stay right on its own. A feedback loop in the rock, and a thermostat that only has one direction left to go has a limit, which is the whole of tonight in one sentence. Now, one more thing about the star, because it puts the timescale into a different frame. The sun is about 4.6 billion years old, and it has roughly 5 billion left before it leaves its stable period. So by the ordinary way of counting a star's life, it is not quite halfway through, which sounds like an enormous amount of remaining time, and it is, for the sun. The problem is that this planet's window does not run to the end of the sun's life. It runs to the point where the sun's steady output crosses a threshold that has nothing to do with the star and everything to do with the chemistry of a small rocky world in a particular orbit. That crossing happens around a fifth of the way into the sun's remaining lifespan. 4/5 of the star's stable existence takes place after this planet has stopped being able to support anything that breathes. There is a version of this that applies to every world in every system, and it is the useful general lesson. You have almost certainly seen a habitable zone drawn as a ring around a star. That is how it gets taught, and it is misleading. The ring moves. It moves outward continuously for the entire life of the star, and any world inside it is only inside it temporarily. Being in the habitable zone is not something a world is. It is something a world is passing through, on its way out the far side. Venus went through it and came out the near side. The one you are standing on is still inside. Mars may have been inside it early and lost its air for unrelated reasons, and could conceivably be a reasonable place to be in 1 billion years, long after here has stopped working. That is the arrangement. One star, a moving band, and a set of worlds passing through it at different times, none of them permanently. The band keeps sliding. The compensation runs out. That is the whole story, and it is going to be worth spending real time on, because the way it runs out is the cruelest piece of arithmetic on this planet. Plants starve to death because of rain, and they make the rain worse, and that is the trap. Here is the mechanism, and it is the one piece of machinery in tonight worth understanding properly, because everything else follows from it. Rain is slightly acidic. It picks up carbon dioxide on the way down, which turns it into a weak acid, and when it lands on rock, it dissolves a little of it. The dissolved material runs into rivers. The rivers carry it to the ocean, and in the ocean it ends up locked into limestone on the seafloor with the carbon inside it. That carbon is now out of the atmosphere. It goes down with the seafloor, gets carried into the interior of the planet, and comes back out of volcanoes millions of years later. So there is a loop. Volcanoes put carbon dioxide in. Rain and rock take it out, and the rate at which rain and rock take it out depends on temperature, because warm and wet weather weathers rock faster than cold and dry weather does, which makes it a thermostat. If this planet gets warmer, weathering speeds up, more carbon dioxide comes out of the air, and less heat gets trapped, and it cools. If it gets colder, weathering slows, carbon dioxide comes out of the air, and less heat gets trapped, and it cools. If it gets colder, weathering slows, carbon dioxide builds up, and it warms. That loop is the reason there has been liquid water here continuously for 4 billion years underneath a star that has strengthened by 30%. It is the single most important thing about this planet, and almost nobody has heard of it. Now the trap. The thermostat only works one way against a brightening star. To keep the temperature steady while the sun gets stronger, it has to keep pulling the carbon dioxide down, lower and lower, permanently, forever, because the sun never stops. And plants are made of carbon dioxide. That is not a figure of speech either. A tree is mostly carbon that was in the air, pulled out of it through the leaves and assembled into wood. Take the carbon dioxide out of the atmosphere and you are removing the raw material that everything green on this world is built from. So the process that keeps the planet cool enough to live on is the same process that removes the substance every living thing on the surface depends on. There is no way to have one without the other. The cooling is the starvation. They are the same event. Now the numbers, because the margin is smaller than it sounds. The atmosphere right now holds somewhere over 400 parts per million of carbon dioxide. Before industry it was around 280. Ordinary plants, the kind most trees and most crops are, stop being able to photosynthesize somewhere below about 50 parts per million. There is not enough to work with. The machinery runs backward and the plant loses more than it gains. So the distance between the air that grew every forest on this planet and the air that cannot grow anything is a factor of about 5 or 6. That is the whole margin. Everything green that has ever existed here has lived inside it. There is a second kind of plant that does better, and its existence is a piece of evidence people rarely connect to this. Some plants use a different arrangement, which concentrates carbon dioxide internally before using it. It is more efficient at low levels, and it lets them keep going down to around 10 parts per million rather than 50. Corn does this. Sugarcane does. Most of the grasses on this planet do. And here is the part that matters. That arrangement is recent. It appeared and spread widely only in the last 30 million years or so, which is very late in the history of plants. It appeared because carbon dioxide was already falling. So this is not a hypothetical future stress. Plants on this world have already had to respond to the thermostat squeezing them once, within the era of animals, and a large share of the plant life on the surface today is the result of that response. The grasslands are an adaptation to carbon dioxide starvation that has already begun. Now the cruel part, and this is the sentence I would keep if I could only keep one. Plants accelerate the thing that kills them. Roots break rock apart. Soil holds water against stone far longer than bare ground does. The chemistry around a living root is much more corrosive than plain rain on plain rock. Land plants speed up the dissolving of rock by a large factor, and they have been doing it since they spread across the continents around 470 million years ago. Which means every forest that has ever grown, including whichever one is nearest to you tonight, has been drawing the carbon dioxide down faster than it would have gone on its own. Every root system pulls the ending closer. They are not doing anything wrong. They are doing what everything alive does, which is grow and consume and change the place it is in. It happens that the change runs in the direction of removing their own raw material, and it runs far too slowly for any of it to matter to anything that is currently alive, including you. It is the clearest example I know of a system that cannot help but end itself, with nothing at fault anywhere in it. Now what happens when the line is crossed? The land goes first, because land plants are the ones with the higher requirement and the most exposure. The forests thin and do not come back. Then the grasses, which last longer, and then those go too. The ocean holds on longer than the land. Marine algae have their own ways of concentrating carbon dioxide from seawater and can work at lower levels than a tree can, so there is a stretch where the continents are bare and the ocean is still green in places. But the same squeeze reaches them, and when it does, the last significant source of oxygen on this planet stops. That is the moment the model is pointing at. Not a catastrophe, not an impact or an eruption or a flood, just the point on a long, slow curve where the amount of one gas in the air drops below what photosynthesis requires, and photosynthesis stops, everywhere, for good. Everything else tonight is downstream of that single crossing, and I want to name the thing that makes it different from every other ending anybody worries about, because it is not the scale, and it is not the timing. It is that nothing goes wrong. There is no failure anywhere in this. The star behaves normally. The thermostat works exactly as designed and keeps this planet at a livable temperature right up until the end, which is the point. The plants do what plants do. The rain falls, the rock dissolves, the rivers run. Every part of the system performs correctly, and the correct performance of every part is what closes it. There is a piece of evidence for all of this that is sitting outside your window, and almost nobody knows what it is evidence of. Grass is new, not new in the way a species is new as a category. For most of the history of land plants, there were no grasslands anywhere on this planet. Forests, yes, going back hundreds of millions of years. Ferns, then conifers, then flowering trees. But the open grass-covered plains that make up a large share of the land surface today are recent, and they spread widely only in the last 20 or 30 million years. They spread because carbon dioxide was falling, and they were better at low levels than the alternatives, which means the prairies, the savannas, the steppes, and every animal adapted to living on them, including the ones that eventually walked upright on the East African ones, exist because this planet was already part way into the squeeze that eventually ends it. The grass is the first response to the process in this video. We evolved on the first response. That is not a mystical connection, and I am not going to make more of it than it is. It is simply that the same slow removal that closes this world down was already reshaping it 20 million years ago, and everything about the landscape you live on reflects that. Now, a fair question that anybody would ask at this point. Human activity is currently putting carbon dioxide back into the atmosphere at a considerable rate. Does that help? No, and the reason is scale rather than direction. Every bit of carbon that could be released by burning everything available would be a rounding error against what the weathering process removes across hundreds of millions of years. The fossil carbon on this planet is a fraction of one cycle of a system that has been running for 4 billion years, and once it is out, the same rain and the same rock take it back down again over a few 100,000 years. The two things are not comparable, and they operate on completely different clocks. One is a spike lasting a few centuries, the other is a slope lasting the life of a planet. It is worth being clear about that, because the deep future here has nothing to say about the present and should not be used to. They are separate subjects that happen to involve the same molecule. Now the last piece of the mechanism, which is what happens to the carbon that gets removed. It does not disappear. It goes into limestone on the ocean floor, and the ocean floor goes down into the interior of the planet, where the plates meet, and the carbon comes back out of volcanoes millions of years later. That return is what has kept the whole thing balanced, but that return depends on the planet still being geologically active, on heat in the interior driving plates around, and that heat is finite. It has been leaking away since the world formed, and it does not get replaced. Eventually the plates slow and then stop, and when they stop, the carbon that goes down stops coming back. That is a longer story than tonight, and it is well beyond the window we are discussing. It is worth knowing only because it means the carbon dioxide does not just get squeezed, it eventually gets locked away permanently. The thermostat does not merely reach its limit, it runs out of the thing it was regulating. Which is worth holding, and it is also not the last word, because there is a more recent paper that says the crossing comes considerably later than that, and it deserves a proper hearing. Earlier this year, a paper came out that roughly doubles the answer, and the honest position tonight is that it might be right. It was published in 2026 in the Journal of Geophysical Research by Jacob Hack-Misra and Eric Wolf. One works at a research institute called Blue Marble Space, the other at the University of Colorado. The work was funded through NASA's exobiology program, which tells you what the actual question was, and we will come to that. What they did differently was give the planet its geography back. Almost every earlier estimate, including the one this whole night has been built on, treats this world as a single number. One temperature, one level of carbon dioxide, one set of conditions averaged flat across every square mile of it. That is a reasonable way to work, and it is how the question has been handled for decades. It is also obviously not what you live on. Hack-Misra and Wolf put the world back. Air moving from place to place, cloud forming over some regions and never over others, poles that behave nothing like the tropics, and the dry middle of a continent behaving nothing like a wet coast. And a world with weather in it turns out to stay alive longer than a world flattened into an average. Their figures run like this. Under strong weathering, the conventional starvation limit is reached at about 1.35 billion years from now. If plants can actually keep working down to lower levels than the conventional limit, which recent work suggests they might, that stretches to about 1.64 billion. Push the limit lower still and it reaches 1.84 billion. They also looked at heat rather than starvation and found that under weak weathering, the planet becomes too hot for most land plants around 1.68 billion years from now, and too hot for all of them around 1.87 billion, which is a striking place for those two numbers to land, because 1.8 billion years is also roughly when this planet loses its oceans. So in their picture, the plants hold on almost exactly as long as the water does, and the two endings arrive together instead of a billion years apart. Now, how much does that actually change? Less than the headline suggested, and I want to be precise about why. The two papers are not asking the same question. Ozaki and Reinhard wanted to know when the air stops being breathable. Hack, Misra and Wolf wanted to know when the last plant on land dies. Those are different endings, and the plants have to go first. They also do not agree about one number, and that single number is where the whole difference lives. It is the level of carbon dioxide at which a plant simply cannot work anymore. The usual figure for the efficient plants is around 10 parts per million. Work published in 2024 argued the true floor might be closer to 3. And if that is right, everything alive on this world gets hundreds of millions of extra years. Nobody has ever watched a plant reach that floor, because you cannot grow one in an atmosphere that does not exist yet. It is worked out from the chemistry, and the answer has a wide range on it. So the honest summary is this: there is a real and unresolved disagreement about whether the answer is around 1 billion years or around 1.8 billion, and it hinges on a threshold nobody has been able to pin down. And here is why I do not think that undermines anything in tonight. Look at where all of the estimates land. The low ones are around 900 million years. The high ones are around 1.9 billion. Every serious attempt anybody has made, by different routes, with different assumptions, decades apart, lands inside that band. Nobody gets 10 billion years. Nobody gets 50 million. The spread is a factor of 2 on a question about the deep future of an entire planet, which is a remarkably tight agreement for something this far out. That convergence is the informative result, and it is not the one anybody reports. What every approach agrees on is that this world has somewhere between 1 and 2 billion habitable years left, that the end comes through carbon starvation rather than through anything dramatic, and that the oxygen goes with it. The argument is about which end of a fairly narrow window. It is not about whether there is a window. There is a lesson in how this reached you that is worth 10 seconds. 5 years ago, the headline was that Earth has 1 billion years left. This year, the headline is that Earth has 2 billion years left. Read casually. Those look like science contradicting itself, and that is how a lot of people file it. They are not contradicting each other. They are two careful groups making different assumptions about one poorly known threshold, and both saying so plainly in their own papers. The useful question, whenever a claim like this arrives, is what had to be assumed to get the number. In this case, the answer is a single figure, the carbon dioxide level at which a plant stops working, and once you know that, both papers become easy to hold at the same time. There is one more thing in the newer work worth naming, because it changes what the whole exercise is for. Hack, Misra and Wolf also ran the numbers on moving your planet. If the orbit were pushed outward, gradually enough and far enough, the livable period runs well past any of these figures. They put it down as an option, not a plan, not a prediction, and not something anybody has the faintest idea how to do. Just a line noting that the physics does not forbid it, which is a strange sentence to find in a paper about when the last plant dies. I find that a strange and slightly moving thing to encounter in a climate paper. two researchers working out when the last plant dies and adding a line pointing out that the deadline is not technically fixed if somebody ever wanted to move a world. Nobody is going to. It is almost certainly not possible. But somebody did the arithmetic and wrote it down, which is the same instinct that produced every other number in tonight. Either way, the ending arrives. 1 billion years, or 2 billion, the oxygen leaves this atmosphere, and the last thing that ever breathed here does it and then stops. The reason the newer answer runs longer comes down to one word, and the word is refuges. If you flatten this world into a single number, then when that number crosses the line, everything crosses at once. Nowhere is left. Every living thing on the surface runs out on the same day. That is not how a world dies. The tropics and the poles are different places. A wet coast is not a dry interior. Some ground sits under cloud most of the year, and some almost never does. So when the conditions get hard, they get hard unevenly, and something always holds on somewhere longer than the average says it should. That is the whole difference. Not optimism, refuges. The flattened version has none, and a real planet always has some. The same thing runs the other way, and the paper is honest about it. Put the geography back, and there are also places that die early. Whole regions stop being livable long before anything global goes wrong, and the dying starts a very long time before the end does. So the truer picture is not a longer deadline, it is a longer, messier, more staggered dying, with parts of this world already gone, while other parts are still green, spread across hundreds of millions of years, which is almost certainly what actually happens. It is also much harder to put one number on, and one number is what gets reported. There is a last piece of honesty that belongs here rather than buried at the end. Nobody has ever checked any of this against a real case, because there is no second case. There is one living world, seen once, from the inside, with nothing to compare it to. Everything tonight is built out of chemistry that is well understood on its own, assembled into a whole planet nobody has ever been able to watch for 1 billion years. That is not a reason to throw it out. It is the ordinary situation for anything about the deep past or the deep future, and the same reasoning reconstructs this world's history and gets it right. It is a reason to hold the numbers loosely and the direction firmly. The direction is not seriously disputed by anybody. The sun brightens, the thermostat responds by lowering carbon dioxide, plants have a floor, the floor gets reached, and oxygen is a byproduct of the plants. Every link in that chain is ordinary chemistry that anybody can check. What is uncertain is the timing of the last two. Either way, the ending arrives. 1 billion years or 2 billion. The oxygen leaves this atmosphere, and the last thing that ever breathed here does it, and then stop. Which leaves one question, and it is the one the research was actually about the whole time. Not what happens to us, what it means for everywhere else. This is what the paper was actually about, and it is not about us at all. It is about the possibility that we have already looked at living worlds and written them down as dead. Here is the situation. When anybody searches another planet for signs of life, the thing they look for first is oxygen. It has been the primary target for as long as the search has existed, and there is an excellent reason for it. Oxygen cannot sit in an atmosphere by itself. It is too reactive. Left alone, it attacks the rock and the surface and anything else available, and it is gone on a timescale of millions of years, which is nothing. So if you find a planet with a lot of oxygen in its air, something has to be putting it there continuously. And the only thing anybody knows of that does that, at that scale, is life. That logic is sound. It is one of the cleanest inferences in the whole business, and it is why every telescope built or planned for this purpose has been designed around finding that one line in a spectrum. Now put tonight's number into it. This planet is about 4.5 billion years old. Life has been here for something like 3.8 billion of those years, possibly longer, and for the first 2 billion of them, there was no detectable oxygen at all. Even after the first rise, the levels sat low for another 1.5 billion years. Low enough that finding them from another star would be extremely difficult and possibly impossible with anything anybody can build. Strong, unmistakable. Easy to spot oxygen has been in this atmosphere for something like the last 600 to 800 million years. Add the billion or so still to come. Run that against the whole span, and the window in which this world is visibly alive covers well under half the time it has actually been alive. Depending on how you count, it could be a fifth of it. You are sitting inside that window right now, and it is the only reason you can see it at all. Which means the following, and it is the sentence that reorganizes the whole subject. If somebody had pointed a telescope at Earth at a random moment in its history, the most likely result is nothing. An ocean world with weather and cloud and water and an atmosphere and no sign of anything living on it. And they would have been looking at a planet absolutely covered in life, at every point, in the water and the sediment and the rock, in quantities beyond counting. They would have recorded it as dead and moved on. Now turn that around and point it outward. The telescopes running right now are looking at planets around other stars and reporting what is in their air. Some of those reports come back with no oxygen. What tonight says is that a result like that carries almost no information, not a little information, almost none, because the state it is finding is the state a living planet spends most of its existence in. The absence of oxygen on another world is entirely consistent with that world being full of life, and having been full of life for billions of years, and remaining full of life for billions more. We have been running a test that only detects a phase, and treating a negative result as an answer. There is something worth sitting with in how that connects to everything else. The sky is empty. Nothing has answered in 65 years of listening. Every world anybody has examined closely is dead. And Mars had rivers and lost them, and Venus probably had an ocean and boiled. All of that has been taken, reasonably, as evidence that living worlds are rare. And here is another explanation that requires nothing exotic. Living worlds may be common and mostly invisible, because the signal we decided to look for is one that a living planet only produces during a narrow stretch in the middle of its life. I am not claiming that is the answer. It is one possible reason among several, and it does not resolve anything on its own. But it is a reason that follows directly from a measurement about our own atmosphere, rather than from speculation about anybody else's, and that makes it worth more than most of what gets offered. Now the constructive part, because there is one, and it is what this field has actually done with the finding. If oxygen is only visible during a phase, then look for something else. The air that replaces yours is not featureless. It is thick with methane, holds very little carbon dioxide, and has no ozone at all. That mixture is strange. Those gases should react with each other and settle down into something stable, and if they are not settling, then something down there is pushing them out of balance and has not stopped. That imbalance is a fingerprint of something alive. It is not as clean as oxygen. It is harder to read, and geology can fake it in certain cases. But it is there, and it can be found, and it is present during exactly the long stretches when oxygen is not. So the world that replaces yours is not an invisible one. It is a living world that fails one test and passes a different one, and nobody had built the instrument for the different one, which is why the paper exists, and why NASA funded the follow-up work, and why two people who study rocks and ocean chemistry ended up writing about the deep future. They were not trying to tell anybody when the world ends. They were trying to work out what a living planet looks like from a long way away across its whole life, so that the next generation of telescopes is not built to find only the version of Earth that happens to be outside the window right now. There is a last thing about this that I keep turning over. The whole exercise depends on having exactly one example. Everything anybody knows about what a living planet looks like comes from this one, and we are looking at it from the inside, at one moment, during the most unusual phase it has ever been in. That is a poor basis for research, and it is the only basis available. And the correction that came out of it is not a small one. It is the realization that the thing we were using to identify life is a temporary feature of the only case we have, and that the case we have spends most of its existence failing its own test, which is a strange kind of progress, not a discovery about another world, a discovery that the instrument was calibrated on a snapshot. There is a case running right now that shows how hard this is in practice, and it is worth knowing where it stands. A planet called K218b, about 124 light-years away, has been examined repeatedly by the James Webb Telescope. There were reports of a molecule in its atmosphere that on this world is produced almost entirely by living things in the ocean. The reports were cautious, the coverage was not, and within months, other groups had reanalyzed the same data and found the signal much weaker than claimed, or not clearly there at all. That is not a failure. That is the process working, and it is the same process that produced the disagreement about how long this planet has left. What it shows is how thin the evidence is at this range. A handful of photons, spread out into a spectrum, from a planet whose light is drowned by a star sitting right next to it. Every claim at that distance is fragile, and every one of them should be expected to move, which makes the finding in tonight's paper more important rather than less. If the signals are that hard to read, then choosing the right signal to look for is most of the work, and the standard choice turns out to have been calibrated on a fifth of one planet's life. There is a practical consequence to all of this that is already changing what gets built. The next generation of large space telescopes, the ones being designed now to look specifically for life on worlds like this one, have to decide what they are optimized for. Optimize for oxygen, and you will find the planets that happen to be in the window right now. Optimize for a broader set of imbalances, and you will find more, less certainly. That is a real design trade-off being argued over by real people right now, with limited money, and the answer determines what the search finds for the next several decades. The billion-year number in this video is part of that argument. That is what it was for. Now the last thing, and it is not about instruments. There is something worth noticing about the position we are in, and it is not comfortable. We can see the ending, not vaguely, and not as a myth or a warning, as a calculation, with a mechanism from ordinary chemistry, with error bars, published and argued over by people who mostly wanted to know something else. No other species that has ever lived here had that. Nothing else on this planet has ever known that the air was temporary, or that there was such a thing as a planet, or that there was a star, or that the star was changing. The knowledge arrived very late, and it arrived in a stretch of about 100 years, and it is not going to be useful for anything. It is simply true, and there is a certain amount of dignity in a species that can work out its own conditions and then say so plainly without needing it to come out well. That is where the science stands. What is left is what all of it adds up to, and it is worth pulling the threads together before the night ends. Let's pull every thread we've followed tonight together. 2 researchers built a model of this entire planet and ran it more than 400,000 times, and the answer that came out was 1.08 billion years of breathable air, give or take about 140 million. The end of it is not a slow fade. The collapse runs in something like 10,000 years, which is a shorter stretch than the one between the last ice age and tonight. Almost nothing dies of suffocation. The plants go first, because the plants are the machine that makes the oxygen, and everything that eats plants goes after them, and the air is still perfectly good while all of that is happening. What replaces this atmosphere is mostly the same atmosphere. Still 4/5 nitrogen, still thick, still with weather in it, full of methane, with no ozone at all, and with almost no carbon dioxide, which is the opposite of what everybody pictures. There is no ozone because ozone is made of oxygen, so ultraviolet reaches the ground at full strength, and the only places left are underwater and underground. What survives is what was here before oxygen and never left. Microbes in the mud, in the sediment, in the rock miles down, around vents on the ocean floor running on the heat of the planet rather than the light of the star. For them it is not an ending. Oxygen was the catastrophe. This is the catastrophe lifting. Nothing complex comes back afterward, because burning food with oxygen releases roughly 15 times what the alternatives do, and bodies and muscles and nervous systems cannot be paid for on the low-yield chemistry. 2 billion years without oxygen produced nothing bigger than a mat. All of this happened once already, running the other way. Oxygen arrived about 2.4 billion years ago, and you can go and put your hand on the rock that recorded it, striped red and dark, in Australia and Minnesota and South Africa. It killed most of what was living at the time, then destroyed the methane that had been keeping the world warm, and froze the entire planet for something like 300 million years. The worst thing that ever happened here, and the reason you exist are the same event. The reason it ends is a star doing nothing unusual. The sun gets about 10% brighter every billion years because helium is building up in its core, and it was only 70% as bright when this planet formed. This world has stayed livable underneath that by steadily removing carbon dioxide from its own air. Rain picks up carbon dioxide, dissolves rock, and carries the carbon to the seafloor, and the warmer it gets, the faster that runs. That is a thermostat, and it has held the temperature for 4 billion years, and it is also the thing that kills everything, because plants are built out of the gas it removes. Ordinary plants fail below about 50 parts per million. The efficient ones fail below about 10, and plant roots speed up the weathering that takes it away. So every forest that has ever grown has pulled the deadline closer. The grass outside is already the first response to it. Grasslands spread in the last 20 or 30 million years because carbon dioxide was falling, and everything that lives on them, including the animals that eventually walked upright on the East African ones, arrived after the squeeze had started. A paper published this year using a full climate model with actual geography in it says the ending comes later, somewhere between 1.6 and 1.9 billion years, closer to when this planet loses its oceans anyway. That disagreement is real, and it hinges on one number nobody has measured, which is the exact level at which a plant stops working. But every estimate anybody has produced lands between about 900 million years and about 1.9 billion. Nobody gets 10 billion. Nobody gets 50 million. The spread is a factor of 2 on a question about the deep future of a world, which is remarkably tight agreement, and the agreement is the part nobody reports. And the reason any of this got calculated is not us. Oxygen is the thing every telescope looks for on other worlds, because oxygen cannot stay in an atmosphere unless something is continuously making it. That inference is sound. The trouble is that this planet only shows it for a fraction of its life. Point a telescope at Earth at a random moment in its history, and the most likely result is an ocean world with weather and no sign of life on it, while it is covered in life. Which means finding no oxygen somewhere else tells you almost nothing. We have been running a test that only detects a phase and reading the negative result as an answer. So here is the honest bottom line. The air you are breathing is not a property of this planet. It is a condition this planet is passing through, produced by living things, sustained only while they keep producing it, and scheduled to end for reasons that have nothing to do with anything anybody does. It began about 2.4 billion years ago. It has somewhere between 1 and 2 billion years left. And on either side of that stretch, this world is exactly what it has been for most of its existence, which is alive and enormous and unbreathing. We are inside the exception. That is the whole thing. Every animal that has ever existed, every forest, every ocean full of things swimming, everybody who has ever taken a breath, all of it sits inside one window in the middle of a much longer story, and the window has edges on both sides that can be dated. Nothing about that is a warning, and nothing about it asks anything of you. There is no version where it matters to anybody alive, and there is no action attached. It is simply the case, and it took 4 billion years of this planet building things for something on it to be able to work it out and say so. The last living things here will be in the dark, around vents on the ocean floor, running on the heat of a cooling world. They were the first ones, and they will be the last ones, and the entire history of everything with a body will have happened in between while they were busy doing something else. Tonight, the air is still here. It came from organisms in the water 2.5 billion years ago. It is being replaced continuously by things too small to see, and there is a great deal of it left. Thank you for staying with me tonight, or for leaving it on while you slept. Either one is fine. If you want another, subscribe and it'll be here. Somewhere over you right now, there is a layer of ozone made of nothing but rearranged oxygen, catching ultraviolet that left the Sunday 8 minutes ago, and it has been doing that without interruption for longer than there have been animals to stand underneath it. Good night.